parallel plates. One was plus, the other one was minus. Remember, we did some small derivations. So that is what is happening inside a capacitor. You have something called plus plate on one side and have minus plate on other side. Okay. The reason I just brought up this was at least you get some kind of a practical understanding. Okay, because we have been doing so much of theory and derivations, and of course it's very, very boring, right? Only when you get a practical understanding, it will make more sense. Okay. So I am going to say this is on one side it is plus, the other one is minus. Okay, just observe what happens here. Is able to see that? What do you think is happening? Why? Nothing, it's very little, right? So the plus and minus kind of combining together to become neutralized, right? That's what is happening, right? So you have some kind of plus here. So if I take the capacitor like this, and let's say I have a lot of pluses here, I have a lot of minus here, right? When you bring it together, what happens? So the plus flows this way, or in other words, electrons are flowing this way. Make sense? That is why you are seeing some sparks, okay? Because the air in between the gap is getting ionized, right? Have you seen sparks when you are pushing this plug inside, right? When you have the switch on and when you try to put it, sometimes you will see some sparks. Why? The switch should be switched on. Only then it will work, right? It will show you some spark. Shock is different. I'm talking about the spark.
That is AC, so it's positive and negative changing at the same time. Or you plug in, the thing is only positive and negative. So sign you change or something.
It's not very complicated. It's same like this one. So what happens is on the live wire, let's say you have plus, right? So when you bring the metal contact, right, using your plug, so the gap is getting smaller and smaller. When the gap is so small, right, there is a situation where the air will become a conductor. Okay. Generally speaking, if I switch on the plug there, right, do you think I am going to get any shock? No, right? Because why? Air is an insulator. It insulates us. But if the gap is very, very small, it can actually conduct. Okay? We'll be talking about this later. It's called dielectric strength. Okay? So make a note. So insulators can become conductors. Insulators can become conductors. When it crosses the dielectric strength.
What is the dielectric strength?
Dielectric strength. We'll talk about this more. Just an introduction. So what can you say about the charges and the voltage? How are they related? If I have more charges, voltage will also be
more. Voltage remains
okay.
So charges is regulated by
Okay. So as I said, water is equivalent to charge. So what can you say about water flow? Electricity, right? Current flow or charge flow. Charge flow is nothing but current electricity. Right? So I told you many times it's very hard for us to understand the electricity concepts. But if you think in terms of water, it's very easy, right? So if I take a container, if I fill this with water, and if I make a small opening here, it will flow out, right? So when you are taking water from your water dispenser, would you like to have the water level here, or would you like to have the water level here? Here? You go to drink water, right? So would you like to have the water level somewhere here? Is this preferable, or filled up situation, is that preferable? Filled up situation, why?
Because then only water will come fast.
When it is here, the water flow will be very, very slow. Okay. So let's talk about the level. So when the level is bigger, the water flow is more. So what can you say about level? What is that equivalent to here?
Flow.
Pressure, yeah. So level is nothing but pressure, right? So rho GH, did we study this last year? So higher the level, more pressure, rho GH, right? Pressure due to the liquid column. So here I am going to say level or pressure is equivalent to voltage. Okay, we have not been introduced to voltage yet, okay, formally. That's what we are going to study in this second chapter, voltage. What is voltage? Okay, so if I had more level, the water flow will be more. If I had more voltage, current flow will be more. Have you studied this somewhere? What law is that? Voltage and current. Bernoulli's. Voltage and current, Bernoulli's. Ohm's law, right? Higher the voltage, higher the current. Higher the level, higher the water flow. Make sense? Okay. So if you have this understanding, it's very easy to understand a lot of difficult concepts. Okay. So now I am going to say capacitor is nothing but a small water tank. Okay. Yeah.
It's also a kind of battery.
Good question. So battery is also storing energy. Capacitor is also storing energy. But battery is storing energy in the form of chemicals, right? There are a lot of chemicals inside. I'm sure you have studied something in chemistry, right? So when there is some reaction, it's generating plus and minuses. Okay, so that is chemical way of storing the energy. Okay, so take it down. Battery stores energy in the form of chemical energy. Okay. Capacitors, what can you say? How is it storing? Electrical energy. Yeah. So let's going to go through the resistor, right? Can I just a sec. Let us first charge this. So first I'm going to charge this. Okay. So I said just few seconds is sufficient. Can you check it and tell me what is the voltage in this?
Yes, sir.
So what is the voltage? 8 point something. Okay. Last time what we did was we directly connected it to the LED, right? So now I am going to connect it through a resistor. So it's going to go from here, right? Connect the other end to this one. So it's going to go from plus to. Take another wire and put the other connection here. Yeah. So from the plus it has to go to the plus here. connected to the plus. Yeah, this has to go. So if I hold it like this, let's see what happens. Can you see that?
Yes.
So what's the difference between the previous time and now?
It's taking longer.
It's taking longer time. So what do you think in the water analogy? What can you say about the resistor?
Like a tap.
It's like a tap, very good. So it's controlling the flow of water, right? So resistor is controlling the flow of current, flow of charges, okay? So you see, so instead of connecting the capacitor directly to the LED, we are connecting it to a resistor, which means it's controlling the charge flow.
So now if you connect the battery related to
Yeah, you can. Yeah, what he's saying is like this, so plus to minus. You see, I removed it, but still it was charged in few seconds, right? So within 1 second it was charged, or not even 1 second, less than that. It stores the energy and then it's giving back, stores some energy, right? So this is the most important understanding of capacitor, right? So now you know there is something called charges really, right? Instead of thinking that okay, we are always looking at the board and putting some pluses and minuses. Okay. So make a note here. Tap will be equivalent to resistor. And very often we have to talk about circuits, right? As we do some circuits, we need to talk about this. So the capacitor is shown like this. All these pens are gone. Okay. So this is how we represent a capacitor. Why? Because there is something called a plus plate and there is something minus plate. Okay. So the very first one which we did was the capacitor was directly connected to the battery. So when I do it like this, what happens? This gets plus, this gets minus. Right? Now if I take this capacitor and if I connect it to the LED, right? How do you show LED? Any idea? Bulb?
Like green. Like an arrow with like
triangle, right? So it will be something like this. This is how the LED is shown. So what will happen? The plus will flow this way. We say the current is flowing this way, but actually electrons are flowing this way, right? This is actually diode. Light emitting diode means you have to show some light coming out. So you show some arrow like this. This is called light emitting diode, LED. Okay. And in the next circuit, what did we do? We took the same capacitor. Maybe you can stand a little bit that way so that you don't hide others. So what did we do? We flow it through a resistor. Right? So earlier what happened, within few seconds, 1 or 2 seconds, all the pluses was flowing through this and coming to the minus, neutralizing. Which means after that there is no more charges. Whereas here it was flowing very slowly. So 1 plus comes here and neutralizes 1 minus, 1 plus comes here and neutralizes another minus. So that's what is happening here. But if you do it slowly, then it will be glowing for a longer time. Are you able to imagine? Okay. So this is what we had here in this circuit. So there is a capacitor, there is a LED and a resistor. That's all. Okay. Let's see what else can I show you. Make it interesting. Anything else kind of interesting? Okay, I will show you one more interesting stuff, which is, let me take a look at this. So come here, and what I am going to do is I will give you the circuit first, and then you have to tell me what will happen. So that's a capacitor, then there is a battery, then there is a LED.
Battery will charge the capacitor.
So what do you think is going to happen now?
Battery will charge the capacitor, and the capacitor will take the LED.
This battery, the light is low.
It's all nothing minus 2.
So assume the light will glow.
It's all nothing minus.
The
Nothing
light
left.
must
No.
brighter.
It comes up the
Very continuous. Very going.
so will it act like a resistor?
The resistor. Okay, somewhat correct, but little more. So let's put this. So Javin, you can connect according to this. So the capacitor is connected here, the LED is connected here, right? Plus from the plus it's coming. So the plus of the battery should be connected here. So plus of the battery goes to the plus of the capacitor, right? So from the battery it's going to the plus of the capacitor. From the minus of the capacitor it goes to the plus of the LED.
So that it continues.
So is everyone observing this? Did you observe that? So I think many of you did not observe, so it just happened quickly. So I want you to check the voltage now. Okay, just check the voltage. No, something happened. Did you watch? What is the voltage? 7.2. So the capacitor is charged or not? Discharged, right? But why? How come the LED is not?
You have to release the flow of the battery.
Okay, let's do one more.
Because it's connected to the wrong sides.
No, but how come then it was glowing for a few seconds, right? So whenever I want to discharge, I don't want the charge now. What should I do? What's the easy method? Just push it close by, right? Don't do this, another safety aspect you should be aware of is, whenever you have some kind of gases or something like that, you should not do this near a petrol station, right? Because you have petrol vapors there. So this may cause a big accident. Okay, don't do this. So you should be careful where you are doing this, right? Make sure. So I'm hoping everything is kind of discharged now. Let's double check there.
7.
What's the voltage?
0.01.
0 point something, which means everything is discharged, right? So now if I put it back, so please observe carefully because it's going to happen only in few seconds. So that's a battery eliminator, right? Battery and then capacitor, and then there is a LED like this, right? So I'm just connecting it to the capacitor.
It's still glowing.
Now it's gone. So now if I again measure the voltage here.
1.6. Will be charged. 7.2.
7.2. So what's going on here? How can you make sense? It is getting charged, but how come LED is not glowing?
So only if you release the battery, the flow of charge on the capacitor will go to the net. Because it's getting charged continuously.
Okay.
So that plus to plus connection.
Plus to plus connection. So suppose if I remove this, right? And if I put it here, right? So like what? So will it glow or not? So it will glow. So because this is plus and this is minus. So I think it got discharged by some means. So what happened? LED is gone. Sometimes what happens, the LED might be gone. So let's repeat one more time just to make sure we are doing correctly. So this goes to the plus because now I'm sure it will be 0 now. Is it 0? Point. So it's 0. So this is plus. This is minus. So from the minus it goes to the plus of the LED. Then this is, so observe again. So maybe the LED is not good, I don't know. Let me check the voltage here. What's the voltage? 8 point something? Okay. So that means what's going on? Something wrong with the LED. Huh? Yeah, so now it was glowing, right? So it means it's
There's no continuity.
Yeah, observe that. So again it's doing the same thing, right? So it's glowing for a few seconds and then it's gone, right? Once this is fully charged, right? Once this is fully charged, again is it 8 something? 7 point something? 7 point something, right? So that means once it is fully charged, this stops. So how to explain that? It's a very important understanding how capacitors work. Yeah, you can get back to see. Thanks. So look at this, it's very easy to understand. So what happens here is, this plus is going here, right? So this becomes plus, right? One of the, or more accurately I should say that, when does this become plus? Only when an electron is pulled from here to here and then put here. So what's happening? One electron from here is getting pulled and then it's sent this way. See if this makes sense. So only then this will become plus and this will become minus.
Because the capacitor reverses the flow after it gets completely charged, the reverse the flow.
No.
Can it go back to the battery?
So the battery is nothing but a pump, right? Again, one more thing. So I can say here, battery does not give charges, it's just a pump. So what happens is it pumps the water from here to here. So this becomes one electron is pulled from here and then it's thrown into this one, right? So this becomes plus, this becomes minus. So when the minus is flowing through the LED, will it glow or not? Yes. And then after a few seconds, one more plus is coming here, one more electron is getting pulled and then it becomes like this.
Once the capacitor is go,
Once it is fully charged, what happens?
it has to do the
I cannot pull any more charge from this. So that means there is no more charge flow in this one, which means there is no charge flow. No charge flow means LED is not glowing. So this is the way a capacitor is actually working. Okay.
So the charge is fully broken.
When it is charging, there is a flow of charges. When it is fully charged, that's all. There is no more flow of charge. That's why I said, it's partly correct, because once it is fully charged, it acts as a resistor because it's not allowing the charges to flow. Okay. Make some sense? Little bit.
So the capacitor has like a larger value in the light bulb glow longer.
Exactly. So instead of this tank, if I had a bigger tank, which means it can store more, right? So what you are asking is, so if I use this capacitor, right, small one, right, which means the tank is smaller, right? Instead, if I use a bigger capacitor, the tank is bigger, which means that this should be able to give more charges, right, for the same voltage. Okay, are you able to see? So let's check that out. So suppose if I give you something like this, plus and minus. It's gone so quickly, right? So let me try it with this LED here. You see, it was so low. Whereas when I was doing with this one, it was glowing for at least 1 or 2 seconds, it was glowing. You can try that one more time. I have a bigger one, but see, it's a little bit longer, right? The bigger one, it doesn't have a proper lead in it. So let's see. You can try this. Doesn't tell me properly which one is plus and which one is minus. So let's try this. You see, it's a little bit longer, right? Because it's charging for a longer time. Because it's a bigger tank. It's still glowing. So suppose if I connect it with this LED, I hope it will be glowing a little bit longer. Let's try that. So again, which one is plus, which one is minus? So this one is plus. See, it's glowing a little bit longer. Still glowing very light. Okay. So if I want to explain that little bit more about that, what happens here is, so I have a small tank like this. I have a big tank like this. Both are filled up to same level, right? Which one has got more charges? This one. But both are charged to the same level. So if this is 8 volt, this will also be charged only to 8 volt. This will also be charged only to 8 volt. But the amount of the capacity is more. So that's why we say this has got a smaller capacitance, this has got a bigger capacitance. Okay, so that's what we are going to study about later. So there's something called capacitance. Okay, so we'll be studying something called charge is proportional to voltage. Okay, more voltage means I can store more charge. What does that mean? It means more level means I can store more charge. Sorry, more water. More level means more water. More voltage means more charge. Right? But then you cannot say, okay, this is also same level, this is also same level. So should it be the same amount of water? No. It depends upon the tank size. Which means that's where we bring in a. So whenever we have proportionality, what do? We bring in a proportionality constant. We call it as C. So that is your capacitance. Okay. So whatever we learned here, right? Nobody is going to ask you in the exams. Okay. So it's all for your understanding. So my expectation is if you understand the basics very well, when you read the theory, it will make more sense to you. Okay. So without understanding what is a capacitor, it's going to be very, very hard. Okay. So I don't think they will ask you any of these things, and all these analogies, don't write it in the exam. Okay. It's only for your understanding. Okay. So unfortunately, the capacitor chapter, it's very, very theoretical. But if you have this practical understanding, it will make more sense. Okay.